Yes, we are live now. Good evening, everyone, and welcome to today's doubt clearing session of our course Metallurgical and Electronic Waste Recycling. We are delighted to have Professor Arunabh Meshram sir with us, along with our teaching assistant Ms. Neha Maurya. Participants, kindly feel free to join the Zoom session and get all your doubts clarified from sir. Thank you. What do you, sir?
Okay. Thank you so much, Murli. So, we are here in this second live session of our course, Metallurgical and Electronic Waste Recycling. And um, based on some of the questions that we have received, we will be discussing uh, some of the doubts that you have asked, and we'll see if we can get some good answers to these questions. So one of the questions is, in lead acid battery recycling, what are the main pollution control measures taken to prevent lead contamination? So generally speaking, as we had discussed in the course itself, lead acid batteries are one of those categories of batteries that have been very thoroughly examined. And generally speaking, most of the countries have good methodologies available for lead acid battery recycling. Now, when it comes to lead contamination will happen maybe at certain spots. Let's say if the recycling process itself is, for that matter, not very properly organized. So there could be lead contamination due to various material flows that are coming in contact with, let's say, land resources, water resources. So under such circumstances, you can have material contact with the environment, and then you can have this lead contamination. Now, apart from that, there is one very important challenge that we were sort of discussing when we were putting up the course content. So one of the most important challenge is the lead acid battery sorting, collection, and storage. So one has to really think, what type of lead acid batteries are we receiving from what source? And are we able to collect it properly? And then are we able to store it properly? So when it comes to lead acid battery contamination, so the pollution that it is creating, one of the most important challenges, are we really taking care of the whole segment of lead acid batteries that are already in the market? So not just batteries that are generated or are being sort of recycled within the fabrication unit itself, but batteries that are in the market. Are all of the batteries really taken care into? Or has it been taken into account? So if this has not been taken into account, it is very difficult to really pinpoint where exactly a certain battery has gone. Because it is possible that if for certain reasons one or two lead acid batteries or sets of batteries are not traceable. So if these batteries are not traced, where are we going to procure these batteries from? Because these are lost to environment. For whatever reason, say for instance, if these lead acid batteries are turning up into, let's say, some dump yard, some steel scrap yards. So these spots are hindsights where people are unable to really identify materials from. And lead acid batteries can end up in certain circumstances like this. If a battery comes in contact with environment, in such locations like landfills or dump yards, it is very difficult to control pollution. Now, while we have very good technologies, generally people have a good control over the recovery of materials, the acids, the lead, everything is taken care of. But if the batteries themselves are difficult to identify, are difficult to trace, then the pollution is a serious concern. Because if a battery is being is, let's say, is isolated from the recycling facility, it becomes very difficult to pinpoint how it is going to affect the environment. Of course, it is going to cause pollution. So yeah, it is very important to really take care of sorting, collection, and separation and storage, because these batteries have to be stored in a uh, very well defined area so that they are properly recycled. Second part, do zinc based batteries have a significant advantage in recyclability compared to lithium ion batteries, LIBs? Zinc based batteries, alkaline batteries, zinc carbon batteries, are all those batteries really having a significant advantage over LIBs over in terms of recycling? So I think that zinc batteries have also been explored thoroughly, just like we've been discussing lead acid batteries. So the recovery of, let's say, iron and manganese alloys, zinc and zinc products, zinc oxide and similar products, this has already been thoroughly well examined. There are pyrometallurgical route, hydrometallurgical route for both types of batteries, uh, zinc-based batteries, and a similar trend is also now being observed for lithium-ion batteries. Now, what do we really mean by, let's say, uh, zinc, by, let's say, recyclability? The challenge is that, fine, we have a source of valuable materials in zinc based batteries. A similar valuable content is also available in lithium ion batteries. The challenge rises when we are trying to identify what valuable material it is, first. Second, if we are able to recover these valuable materials in an economic way. Now, processes are very well developed, and there are numerous routes through which we can sort of picturize one process following the other. But one of the most important differences in, let's say, zinc batteries and LIBs is that the categories of batteries are significantly larger in lithium ion batteries, which makes it a big challenge. So, for instance, you have different cathode materials. And based on this, it is very important to devise a certain type of recycling strategy for LIDs. Let's say you have NMC type of nickel, manganese, cobalt type of composition. There is LCO type of, LMO type of cathode. So when we have different types of cathodes altogether and different types of battery compositions, it requires us to sort of devise the recycling strategy in that particular fashion, and not just inclined towards one particular style of recycling. So, for instance, if we are looking at zinc batteries, it is relatively easier because there are very limited variations, strong variations in terms of compositions. Of course, there are internal variations in terms of how batteries are fabricated by various companies. But generally speaking, we can put some good data on it. It can be found, and we can sort of plan it properly. For with LIBs, the compositions tend to change a lot. So in that sense, it is a big challenge to compare lithium-ion battery recycling with zinc-based batteries. Of course, which is why we have categorized the batteries altogether differently. The major segments of batteries have been identified, let's say LIBs, NIMH, zinc-based batteries, and let's say lead acid batteries. And the recycling strategies have been outlined. This is specifically done to help us understand the challenges within each of these types. And if we are really wanting to compare the battery recycling strategies, lithium-ion batteries are still being explored almost on a very regular basis. And as newer compositions are coming in, newer methods are also being explored. And this would again involve pyrometallurgy and hydrometallurgy, and at times also electrometallurgy, and combinations of these processes, one after the other, to sort of recover valuable materials to make valuable products, if not metallic values, and see if it is working with better economy. So, yeah, these do have differences, if not advantages. I would like to put forth that there are significant differences and not maybe advantages or disadvantages, because both of these battery categories are different, and these should be learned separately so that we understand the subtle challenges present in both of these battery categories. Now, third question is, from an environmental standpoint, how can we ensure that recycling processes themselves do not create new pollution problems? Now, this is a very general and important question that, let's say, if we have a recycling process for any of the wastes that we are, let's say, want to identify as our raw material, it is going to have some process involved. So, for instance, if we have a slag, imagine, let's say, and it is coming from some metal industry. Now, this is a slag or oxide or some pyrometallurgical waste. Now, this waste stream is, let's say, it is accumulated in large quantities. Now, if we do characterization, if we conduct the characterization tests and we identify some elements of importance, okay, such and such elements are in larger quantities. Now, we would definitely like to extract these valuable metals from this waste stream, let's say slag. Now, when this is the target, we would again like to devise a strategy. Say, for instance, there could be comminution, there could be some pre-treatment of activity like, let's say, magnetic separation, or some route is designed. People would like to go into hydrometallurgy or pyrometallurgy. Someone would like to suggest remelting of slags or recovery of XYZ elements. So when we have these types of strategies lined one after the other, we are again bound to generate some waste in the process, because none of the processes that we are uh, having in reality in an industry, none of these processes are operating at 100% efficiency, let's say material efficiency or energy efficiency. So what it generally means is, if we've charged, let's say, 100 grams of something in a process, if we start with 100 grams of raw material and we do something with it, let's say you want to do leaching, the recovery would be, let's say, 65%, 75%, 85%. It could approach, let's say, 90, 95%. But then again, there is some quantity of residual solid generally that is left behind. If we are supposed to really think about it, it's not 100% leaching. So we are still left with some recovery, some residual solid, which was supposed to be recovered, but the process efficiency wasn't good enough. So we are left with some residual solid altogether. Now, what we can do is we can recover this residual solid, do some more pre-treatment, perform some, let's say, change of pH or some other activity can be done, and then it could be made into an inert material for fit for some composite or as a reinforcement material for some composite or for some construction applications. So generally speaking, the overall idea of recycling should be such that it takes care of all these subtle challenges that are present well within the recycling strategy. Because if this is not taken care of, say for instance, if a recycling strategy is designed in such a way that it generates more waste rather than actually recovering some valuables. Now, under such circumstances, we would have multiple streams of materials coming out, which would require further recycling on their own. So, it is very important to note that any process that is being designed is designed in such a way that no new pollutant is affecting the environment. We are not really always so sure that there will be no waste generated at all, because it is almost always the case. What we can think of in the lines is that, in the future lines, is that development of processes can be done in such a way that these wastes that are generated are relatively less environmental harmful. The effects are relatively lesser on the environment. And if it so happens that there are some wastes that are relatively more impacting than others, then some more processing optimization is required in the main route of recycling itself. Or this particular waste stream could be treated in a way that it becomes more environment friendly. Generally, utilization of a waste stream for construction applications or for inert applications is something that most of the recycling industries are targeting. Apart from, of course, the recovery of valuable materials, because valuable materials really help in recovering the economics and the profits for the company. But if there's a waste stream that needs to be uh, taken care of, it generally is made environment friendly before it is introduced into the environment. That is the prime target. I mean, that is how it would be a better way of, it should be planned in such a way. So, from an environmental standpoint of view, uh, it is, of course, important to devise the recycling process in such a way that no new pollution uh, is incurred during the whole process itself. Now, the next question is, how do developing countries like India handle informal e-waste recycling practices, and what steps are being taken to formalize them? Now, generally, it so happens that informal e-waste recycling practices are usually being followed in different parts of the countries almost on a very regular basis. And that is how people have evolved their thoughts on, let's say, recovering valuables from e-waste. Now, it is not just e-waste, it could be for every metal industries. So, for instance, if we have iron and steel, aluminium, or some other metal. So, if we have scraps, there are informal ways of recycling scraps, which are not essentially large smelter units performed by smelting is performed by, let's say, a big industry. Now, informal methods of e-waste uh, would mean that would mean that the the recovery of valuables would be a bit limited. The reason is that the technical know-how of, let's say, e-waste recycling would not be completely known to the informal recyclers because they may or may not perform the essential pre-treatment. It's totally case to case dependent. And at the same time, it can also be hazardous to the people who are involved in the informal method of recycling. Now, I've just pointed out two important aspects. One, the efficiency of the process. We really don't know how they are going to perform the recovery. Second, the process itself may be a bit more on the hazardous side because the it is possible that, let's say, the recycling is done with the components attached. Let's say if you are looking at a printed circuit board or let's say a discarded washing machine or discarded fridge, it is possible that some the components that are attached are really not properly dismantled or removed. So proper pre-treatment that is essential for recovery of valuables that may or may not have been performed. What this really means is that ultimately it is going to affect the person who's going to do the operations of recycling. So, yes, on the two aspects that we have discussed, the recovery as well as the health and environmental impacts. These are a bit of a challenge, and explaining ideas and methodologies to uh, general people for with general awareness has given us so much opportunities to really tap into the e-waste. But at the same time, it has also increased the informal route of recycling, which can be at times hazardous for people who are involved in it. What steps are being taken to formalize them? I believe uh, I believe that through education, people have been able to learn better routes of recycling, and eventually, people are now transforming the informal routes into more formal routes by learning and by expressing their challenges and getting involved uh, with amongst themselves and trying to find solutions. That is how people would like to become more of a united group of recyclers and rather than going into pockets. So yes, people gradually are moving towards uh, making it more formal rather than staying informal because people have now faced challenges which they are now wanting to address. So, and of course, there are so many schemes that are being provided by so many of the uh, administrative blocks that they are being involved in helping people to formalize their own enterprise, and that is how. they'll get formalized. I think this question is mostly on the policy of the recycling and not essentially the recycling strategy or recycling methodology per se. So yes, there are more policies that would be helping the recycling strategies. Recyclers and devising better recycling strategies would help everybody. And general awareness, as I've always put forth, that if there is general awareness amongst people, a better learning would be uh, ensured, and everyone would be able to grow in the proper direction so that this these types of challenges are addressed, and we are able to sort of take care of the recycling problem which we are facing in our country and in the world in general. So I think we have completed the question answer from the Excel sheet. If there are any more questions from the participants, you can please ask.
Thank you, sir, for addressing the queries raised via Google Form. Three learners are here, sir, directly joined on Zoom: Mr. Elavasan, Mr. Lokesh, and Mr. Saji. Do you have any queries? Please unmute yourself and ask your doubts.
Hi, this is Saji. May I ask? Am I audible?
Yes, you're audible. Please
Yes,
go ahead.
please.
Okay, thank you. This is regarding the now the discussion on the policy. My question is if suppose if the batteries are used for domestic purpose like in an inverter or anything, so the domestic user doesn't have much freedom to, because industrial sector means they can have agreement with the recycling facilities or anything, but a domestic user may give it to the shop for a replacement or anything, and we don't know the future of that, what to say, used battery. The shop person may give it to a informal recycling facility or a formal recycling facility. So we do not have good control over this one, but industry sector may have. That is one concern. And another one is I'm wondering, how can a recycling facility informally, I mean, informal setup, how can we make? Because we have to go for a license, and if we want to start a recycling facility, we have to go for a few steps like getting a license and what are we going to recycle. And so I don't know how a informal facility is what is it built. That is the second concern. It's not really question. And another question is like if when we think about the batteries, there are always trace metals. Right? It is not in addition to the main metals. So are we able to recover all these trace elements when we do the recycling? Or sometimes if it is certain below certain percentage, then we have to leave it as a waste. Or is it possible to recover 100%? Another one is, do we have really good control over this recycling? Because we have a control over production. So because we know how many batteries are produced per year in our country or globally, and we know how many batteries are sold uh, in a particular year. But when it comes to the batteries coming to recycling facility, we do not have. I think we don't have exact number, because the end of service can be different. Even we produce some 100 batteries this year, the 100 batteries may not come to an end of service in 5 years. Some may extend to 6 years. So do we have really a control over this one, so that we know, okay, these many batteries are recycled? Or these are not more like questions, but more, yeah, concerns. And yeah, so I like to hear from you. I mean, latest statistics we have or anything. Yeah.
Okay, so there are these are like lot many questions actually. So
I'm
I'll
so
try to
sorry, actually.
yeah. So
Okay.
let me just try to sort of answer them bit by bit. Generally speaking, the uh, domestic applications, single-use batteries. I'm assuming that you are talking about single use batteries. So, and even if it is a rechargeable battery, what really happens is when we have a type of battery and we generally give it out to shopkeepers if it is done or in that way, then we really don't know what happens is what is how you've described the situation. Now, a better way of addressing this challenge would be to have a policy for e-waste and metallurgical waste, because this course is essentially concerning these two broader broader streams of waste. So when we have very well defined policies for different types of electronic devices, let's say television, batteries, washing machines, ACs, or whichever electronic device we are wanting to discard and buy a new one. So in other countries, there are methods of, let's say, buyback and sort of replacing the old device with a newer one. Now, generally speaking, the manufacturer usually would be sort of recycling the waste in the recovered product because it has reached its end of life, and then they use it, reuse it, or dismantle it, or recover the parts from the waste stream, and they are able to take care of the older devices. This type of mechanisms and policies would really help uh, every stream, not just batteries. So right now the question is more focused on, let's say, domestic batteries, but I believe that a better uh, holistic policy for general products, let's say computer monitors or CPUs or printers or televisions, everything can be really brought into the larger umbrella of public domain, wherein public awareness is such that we are not really dumping something in the dustbins or dump yards. We are bringing it back to the source where it has been purchased, and the procurement of newer devices done, and at the same time, the older devices also taken care of. Such support and awareness has to grow amongst people so that it is more accepted, and it will all be more accepted by everybody when all parameters are coming together, let's say administration, market, as well as the consumers. Everybody are coming together for this uh, change of change of thought process. Now, the next question is, it could be related to, let's say, how batteries are recovered, and is it really possible to recover valuable materials to an extensive uh, limits? Generally, yes, it is possible, and some of the, I mean, if it is possible, I would I would suggest that the the literature available right now is very exhaustive on any of the batteries that we have discussed, or something that even that is beyond. People are thoroughly trying to recover materials down to parts per million, ppm and ppb as well. So it is possible to recover valuable materials at the same time, because electronic waste stream can have different types of wastes. It can also have uh, rare earth elements, or PGEs, platinum group elements, or some other different types of elements. Now, these elements could be present in very small, minor quantities. Now, when these are present in minor quantities, and if they are of economic worth, people would like to target these elements as key raw materials that would be sold as a finished product. Now, apart from the main element that is being targeted, let's say zinc or lead in zinc-based battery or lead-based batteries. So if these are present in minor quantities and if they are worth something, then it is always a target of recyclers to sort of uh, recover these elements. But at times it has to be optimized in various different scales. Let's say let's say something is possible at a lab scale. It is very difficult to predict whether this uh, element or the set of elements would be recovered efficiently on a pilot or an industrial scale. So that could be a big challenge. And yes, it is always a big challenge in the sense that we really have to uh, address this problem of collection, sorting, and storage of batteries. And we've just discussed this for lead acid batteries. It is fair for any of these battery types that we have discussed in the course. And it is always important to first isolate the different types of batteries and sort them based on the broader categories. What happens is if we have batteries, we just sort of get a cluster of different batteries of different categories. Now, even in the broader categories, there are subcategories based on composition variations. So altogether, it is a very difficult way of handling recycling methodology. And it is also true that particular type of batteries could be recycled only if they are of certain compositions or if they are really brought to a recycling unit. Now, collection of batteries itself is a big challenge. When these types of challenges are addressed, the overall efficiency of number of batteries and of overall efficiency of recycling and the overall number of batteries recycled would eventually go up. Right now, if a certain statistics tells us, let's say that around 65 or 75% batteries are recycled, this is just a number. What is happening with the rest of the batteries? The challenge is that uh, it is very difficult to pinpoint which battery is sitting for what applications in which of the areas of the country, let's say. So when the batteries are brought back into material cycle, these would certainly be recycled, but these have to be brought back into material cycle. And if these are lost to the environment, let's say if there are batteries packs that are lost to landfilling, then then it again leads to environmental concerns. So I think I've answered most of your questions. If there are any more questions, please ask.
Yes, you answered everything. Thank you. May I add something? Is okay?
Yeah, please.
Yeah, thank you. I mean, this is an example of my place because here we have formal collectors of waste and informal collectors of waste. So, formal collectors of waste, we have to pay certain amount every month. So they come and they have a list of what to say waste collection. This month they collect certain things. This month electronic waste or batteries or sometimes plastics and some. And we have informal collectors too. So they come very often, means without any calendar or anything. So the thing is, because informal collectors, they give us certain money, even if it is plastics or metal or e-waste or whatever. But formal collectors, we have to pay certain amount every month.
Yeah, so this is what
yeah,
I'm trying to explain.
yeah.
The change has to come on every aspect. It's not just let's say people who are involved in
Yeah,
collection and sorting, and it has to come on every aspect. So uh,
yeah,
there are policies in different countries that take care of everything,
yeah,
and it helps everybody to bring the material or commodities or electronic device or whatever it is to a certain location. So when such policies are set, it becomes a lot easier for everybody to accept.
Yeah,
And
exactly.
the anomalies that are present in different cases, these will eventually be taken care of.
Yes. Because of this, people tend to give to informal collectors because they give some amount of money, and formal collectors we pay. So, because of this, I feel like most of the waste, sometimes this hazardous waste also go to informal collectors.
No,
So,
so that is what
yeah,
I'm trying to explain.
yeah.
Collection and sorting is more a big of a challenge than recycling itself, because recycling we have tried to address in the course, and it is a very technical, very well defined set of activities that can be designed basically. The challenge would be to collect the waste itself and
Yeah,
to sort
exactly.
it.
Yeah. So I think we need certain policy changes, and even though people are aware, but still, because we get some money instead of the formal collectors, we have to give money. So because of this, sometimes people think, okay, give it to informal collectors so that gives us some benefit. So I hope it is because of the policy issues. Otherwise,
Yes, this isn't really a part of our course, so we
yeah,
really don't
I agree
discuss
that. I agree that.
policies per se.
Yeah, I agree that.
We discuss the technological roots of
Yeah. I agree that.
yeah.
I just brought this example of my place because I just wanted to share with you that sometimes e-waste goes to informal collectors because of this.
Yes.
Yeah. Thank you so much.
Thank you. Any more questions from any of the participants?
Like one more student have joined, sir, Mr. Arun Kumar. Arun Kumar, do you have any question?
Yeah, Lokesh, you can ask. You were
Sir,
unmuted.
will you be taking up any courses next semester in NPTEL?
I really am not able to comment on this right now.
Okay, sir. Actually, this is from my domain. I am telling about my background. I have done my BTech in Metallurgical Materials Engineering and MTech in Materials Science and Metallurgical Engineering with specialization in semiconductor materials and events. If such any that internship can be offered from your side, that as per NPTEL rules, if it is possible, it will be a great opportunity for us. Uh, you said that you will be telling that.
That would be rather be coming to you through NPTEL. Probably this has been asked previously as well.
Yes, sir.
So if that is.
You said that the last time you can't comment it at that time, so
Yeah. So my answer really hasn't really changed yet.
okay, sir. If we have anything, we will get through NPTEL, sir.
Yes.
Okay, sir.
Sir, for the toppers, usually we offer internship, provided the faculty member should be available to guide them, sir. So
we'll actually see if it is possible, how it turns out.
Yeah. So, Mr. Lokesh, you can apply directly. There is an email. Just search for internship and NPTEL in Google, and there is an email ID. Please write to that email ID, and we formally take it up. We will check with the faculty member, and if he is available, then we can you can come here and do an internship.
Okay. Any more questions?
Ilavarsan is there. Ilavarsan, do you have any questions?
Hello. Nothing, sir. No, nothing. Yeah.
Okay.
So if
So
there are no more further questions, then I think we can close.
Sure, sir. I think there are no queries. In YouTube, 3-4 students are watching, but no questions are posted over there. So we can conclude, sir. Thank you so much, sir, for this live doubt clearing session. You have explained the answers in a very detailed manner with example. It was very, very informative. And thanks to all the participants as well for joining and making the session interactive. We are closing the session now. Thank you, everyone.
Thank you so much.
Thank you, sir.
Thank you.
Thank you.